Actually, first I want to draw your attention to some things that the students would write sometimes in their report, and I'm like, no, this is not right. And it's things that you may hear, but they are not correct. So in your lab manual, I wrote a bunch of things which were things that I read before, and I wanted to just say, okay, what does that mean? So in here, when I say for a p-value of 0.03, and let's say that our critical p-value is 5%. So 0.03 is below the 0.05. And what that really means is that the difference that you see between the things you're comparing is statistically significant because it's below the 5%. And so these are things that people would write. Let me tell you what's the correct or incorrect ones. So people would say that the data are significant. And you're like, oh, sure, because that is lower than that. That means that we found significance. Yeah, you found statistical significance, but it's not in the data. It's the difference between the data that the two groups of data you're comparing. When you say the data are significant, sounds like you're saying your finding was significant finding, or it's not that. It's not that the data are significant. It's the difference between data. Or the data are insignificant. Okay, that one it's really out because that being lower than that makes it a significant difference. Okay, the treatments are significant. That's not true. It's not the treatments or the data. It's always the difference. Experiment did not work. So some people tend to say the experiment didn't work if they see no statistical difference, meaning if this was greater than the critical p-value, then you're like, oh, the experiment didn't work. You can't say that. If the experiment had the right controls, then not finding significant difference, it doesn't mean that the experiment failed. So that whether it failed or not does not have to do with finding a significant difference. The significant differences are exciting, but sometimes you don't want that difference to be to exist. Maybe you're comparing two things that are, deep inside you're hoping that they're not different. As a good scientist, you should not hope for either way, but we're humans, so you might have an inclined to look at things hoping for one way or another. All right, so data are significant, not true. Insignificant, not true. Treatments are not true. Experiment didn't work, not true. Experiment was successful, not true. The difference between variances is significant. Okay, if the variances were the things that are comparing, then that one is true. Not significant, not true, because this is lower than that. Difference between the averages was significant. Okay, that would be true if you're doing a t-test. Variances, statistically speaking, are the same. That would be not true because remember, since there was a statistical difference, if this was the result of an f-test, then that would mean that the variances are different. So then, not the same. That's true, not true. The difference between averages is not significant. That's not true because this is lower than that. Both treatments are the same. No. Statistically speaking, not the same. That's true. The means are not the same, so they're statistically different. Finally, this proves that the two means are significantly different. Okay, that people love to say that prove, but you can't say that. You can say that they support. No, as scientists, we just say we have data to say that this thing, but we never actually say this proves that. And okay, support, that's better. So that's what I would say.